Welcome back, Math 10s. We're going to do 5.2. We're looking at special lines that are related to each other that can be parallel or perpendicular or neither. So let's take a look at this. So these are terms we should have heard before, but parallel lines are lines that never cross each other, so they're always the same distance apart. Generally look something like that. Okay, so they are perfectly parallel. We use symbols like so to indicate that they are parallel. And so they, in other words, graphically, this means they have the exact same slant or steepness, or the term we use in this course and math moving forward is the slope of the line. So we're going to prove whether any of the following line segments are parallel. So we're just going to be comparing their rise over run. So this will be a bit of a review from last day. So we're going to take first, let's find the M, okay, of line EF. We're going to look at these three lines here. So we're going to call that M of EF, of line EF. And so the rise of that, so let's take a look. So we're going from E here to F. Let's get our rise. Goes 1, 2, 3, 4, 5, 6. So this is plus 6. So we're getting 6 on the rise. And our run looks like it's 1, 2, 3, 4. So plus 4 because we're going to the right, which again will always reduce that divide both by 2, of course, and that's going to give us 3 over 2 as our slope. All right, let's look at the next line. So the next slope is M is E of PQ. So P is way down here. We can see from the picture these lines look parallel, but we're going to find out for sure. So let's figure out our rise first. So 1, 2, 3, 4, 5, 6, 7, 8. So I got a plus 8 rise here, and then 1, 2, 3, 4, 5. So plus 5 is my run. So I have a rise of 8 and a run of 5. And right away I can see these are not equivalent. I cannot reduce this fraction to make it the same. So definitely EF and PQ are not parallel. And let's check the last one. Let's switch to green for this. We'll look at our last slope for line RS. Okay, we'll take these 2 points here. It looks like we have a rise of 1, 2, 3, 4, 5, 6. So we have plus 6, and then a run of 1, 2, 3, 4. So again, we're getting the exact same as above. I have 6 over 4 is my rise over run, which is the same as 3 over 2. Therefore, we can say that these two here are parallel. They have the exact same slope, and neither of them would be parallel to line PQ. Another way we could write this is we could take EF, and the way we indicate parallel is 2 straight lines, okay? Line EF is parallel to line RS, okay? So this little symbol here means is parallel to, okay? Another way of writing the exact same answer. Perpendicular lines. Okay, so we know what these are. These are lines that cross each other in such a way that form a right angle, a 90-degree angle. Remember that from trig. Their slopes are, now this is called a negative reciprocal, okay, of each other. Now, what is a negative reciprocal? Well, this just means this part here, negative, is just going to be change sign, okay? We're going to change the sign of the slope. And reciprocal just means flip fraction. Okay? Negative reciprocal. Change the sign and flip the fraction. So a slope of a line perpendicular to a line with a slope of -4. So indicate -4. So this is going to go over 1. The negative reciprocal means a negative of a negative. It's going to change sign. So we're going to be positive now. I'm going to emphasize that with a plus. And the reciprocal will flip it. So the 1 will go on top and the 4 will go down below. So there is a slope that is perpendicular. Next one here, slope of line perpendicular to a line with slope 1 over 2. So the negative of a positive is negative. So I'm going to have a negative now, and I'm going to flip that to 2 over 1. And that's it. That's how you do negative reciprocals. So we're going to again prove that VW and ST, these two different lines here, are parallel, perpendicular, or neither. So we got to compare their slopes. We're definitely not parallel looking at them, but they look close to perpendicular. So let's take a look. So we're going to find first M of VU. And VU, I need to find 2 points. They're indicated for me here. There's one here and one here. So we'll go left to right. Our rise is 1, 2, 3. So plus 3 is our rise. And our run, 2, 3, 4, 5, 6, 7, 8, 9 is plus 9. So we have a rise of 3 and a run of 9. And to reduce that, we can divide them both by 3 to get 1 over 3. Okay, let's check it out with the next slope of, looks like ST. For this one here, we're going to find these 2 points. There's one here and one here. This has a huge rise. Well, going down, it's going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that is negative because we went down, negative 12. And then the run would be 1, 2, 3, 4, positive 4. So we get negative 12 over positive 4. Let's reduce that. That's going to be both divisible by 4. So that's going to give me negative 3 over 1. And we can see, yes, these two are negative reciprocals, or negative recip for sure. So therefore, the way we can write this is ST is perpendicular. So we draw a symbol like this. Some notation will show a little right angle there, perpendicular to line VU. Okay, since they are negative reciprocals. All right, let's take a look at this one. Now we're given 2 points here. A line that passes through P and Q here, and another line that passes through R and S. So this is the exact same question as we just did, except we don't have a graph to count the rise over run. So we're going to use our equation. No problem. So recall that our equation is equal to y2 minus y1, the change in y, that's the rise, and the change in x. So there's our formula. So we're going to use that to check out both these slopes. So let's go to blue maybe. And first I'm going to find the slope of line PQ here. And I'm going to substitute all the values in. So I'm going to set up my empty brackets from my equation. Okay. And now here's let's label these x1, y1, x2, y2. So again, I'm going to subtract here. So I'm going to take my y2 is 10 and subtract 2. And then negative 2, my x2, subtract negative 7. So careful with all the negatives here. 10 minus 2 is going to give me 8. Negative 2 minus negative 7, that's the same as addition here. So it's going to be negative 2 plus 7 is going to give me 5. So there's our first slope of 8 over 5. All right, now let's compare that with line RS. So let's get our slope for RS. We can say what's going on with these lines. Let's set up our empty brackets for our equation and make the quadruple substitution. So let's label x1, y1, x2, y2. Let's take our y's and we go 1, subtract negative 4. And then we'll take our x's. We go 5, subtract negative 3. All right, so careful with those negatives. Another way I like to show that is just simply turning them into giant plus signs. You'll see me do that in class. So 1 plus 4 is 5. 5 plus 3 is 8. And we can see just by looking at this, we are close. Okay, they look like reciprocals, but they are not negative reciprocals. Okay, so this case, and they're not parallel because parallel would mean equivalent or the exact same. So when we compare both of these, okay, when we make this comparison, it is not a negative reciprocal, and it is not equivalent, therefore neither. Okay. One last question. Determine the slope of a line that is perpendicular to this line. So we're going to create a slope, but we first need this line to create that perpendicular slope. So let's first get the slope of line GH. We're given 2 points, G and H, so let's find the slope of it. Let's label it x1, y1, x2, y2. And so we're going to set up our equation. And so we have -2 subtract the 3. And we have 1 subtract the -2. And let's simplify that. So -2 minus 3 is -5, and 1 minus -2, remember that's a giant plus, so that's positive. 1 plus 2 is 3. So there's the slope. So now I need to determine the slope of a line that is perpendicular to that. So a line that would be perpendicular is just taking the negative reciprocal. So let's just do that. Let's take the negative recip. Okay, so we're going to, a negative of a negative is positive, and we're going to flip it to 3/5. So that's going to be, would be, symbol for perpendicular. You can write the word perpendicular either way. All right. And how about parallel? Well, we already just got the slope, so this is as easy as it gets. We can directly just copy it. So m would equal -5/3. This would be parallel because they are equivalent, because they are identical. Okay, and that concludes this lesson. So just in a quick recap, what did we learn? Basically, we looked at special cases where we're comparing lines that are parallel, perpendicular, or neither. And for parallel, the slopes had to be equivalent or equal. Okay, and for perpendicular, they needed to be negative reciprocals of each other. And then we also were able to do that using stuff from 5.1, where we used our slope equation by finding the change in y and dividing it by the change in x using this formula right here. All right, that's it. That's all. We'll see you next time.